guys. In this video, I'm going to talk about a couple formulas. One will be new and hopefully one is review for you. The first one we're going to discuss is something called the midpoint formula. So we know that the midpoint is the point exactly in the middle of a segment. So how do I find the coordinates of a midpoint if I know the coordinates of the two ends? So we have a formula for that. Here it is. Make sure you write this one down. x1 plus x2 divided by 2. Comma, so that'll give us our x coordinate of the midpoint, y1 plus y2 divided by 2. So remember, these little subscripts, you guys, are just saying the two different y's and two different x's. That's all that means, okay? So here I have CD and some midpoint M. So we want to find what is the new coordinates of M, what's the x and y ordered pair, if C has the point -2, -1, and D has the point 4, 2. So I'm going to use this formula. So C is like my x1, y1, my first point that I'm seeing, and then D is like my second one, so x2, y2. So I'm going to do this formula. So it says add the two x's, divide by 2. So here's x1 and x2. So I'm going to do -2 plus 4 divided by 2. Okay? And then I'm going to do the same thing with the y's. Y plus y, so -1 plus 2 divided by 2. And then I just simplify. So -2 plus 4 is 2. 2 divided by 2 is 1. -1 plus 2 is 1. 1 divided by 2, I'm just going to leave that as the fraction. Okay, or you could do 0.5. But that is where M is. Okay, so M has the ordered pair 1, 1/2. That's its location. Okay, we can also kind of work this in reverse. So M is the midpoint of AB, so I'm going to kind of draw myself a picture again. So I have AB, M is exactly in the middle, right? A has coordinates 2, 2, and M has coordinates 4, -3. They want me to find the coordinates of B, so I'm just going to call that XY. Okay, so this one's kind of different. This formula is used to find the midpoint. In this case, I actually know the midpoint. So I'm going to show you guys kind of a nice way for finding the midpoint. So because these are equal distances, right, I'm going to look at how far is it from x to x. So what I mean by that is, what do I need to add or subtract to 2 to get to 4? So from 2 to 4, I am adding, I'm actually going to write this just a little bit different, you guys. We're going to say A, I'm going to write the y's down below here just to give us some more space. Okay, so from 2 to 4, I have to add 2. So because this distance has to be the same as this distance, I also have to add 2 here. So I'm going to, these are my x's up here that I'm working with, and these are my y's. Okay, so 2 plus 2 is 4, so 4 plus 2 would give me 6. So that means my x coordinate of B has to be 6. Now the y is something different's going on. Down here, to get from 2 to -3, I'm subtracting 5, okay? So that distance must stay consistent if M is exactly in the middle. So -3 minus 5 is -8. So that means B has coordinates 6, -8. Okay, so we're just looking at those distances between the x's and the y's to get the new coordinates. And we're basically just using the definition of midpoint to figure out that that's where B must be. Okay, this is the one that should look familiar, Pythagorean theorem. Here it is, a squared plus b squared equals c squared. Reminder, this can only be used on right triangles, and it's used to find the lengths of the sides of a right triangle. Okay, so we have to know 2 of the sides, but we can use this to find the third. So remember, A and B are what we call the legs of the triangle. They're the shorter sides, the sides that form the right angle. And C is the hypotenuse, which is the longest side, and it's always across from the right angle. Okay, so we're going to use the Pythagorean theorem to find this missing side. Notice our directions. It says leave answers in exact form. What that means is not a decimal. We're going to use simplified radical form if I get the square root of something for an answer. Okay, So the hypotenuse is C. That's what we're trying to find. So that means 8 and 15 are A and B, and it doesn't matter which one I make A, which one I make B, as long as they're the legs and not the hypotenuse. So A squared, I'm plugging in the numbers here, A is 8, plus B squared equals C squared. Okay? Follow order of operations, so do the exponents first before adding. So 8 squared is 64, 15 squared is 225. Now I can add, and I get 289. So I don't want to know what C squared is, I want to know what C is. So to undo squaring, we're going to take the square root of both sides. So square root and squaring cancel, and I get C by itself. And actually, 289 is a perfect square. I get a nice whole number, okay? 17 is the square root of 289. So C is equal to 17, okay? All right, find the value of B. So here, I'm still going to use Pythagorean theorem because I know 2 of the sides and it's a right triangle. But in this case, 9 is A, I don't know B, and C is 12. So I'm still going to use A squared plus B squared equals C squared. So A squared is 9 plus B squared, I don't know B, so I'm just going to leave it as B, equals C squared. And C we know is 12. Okay, do the exponents first. 9 squared is 81, okay, plus B squared equals 144. So I'm trying to figure out what B is. So I need to get B by itself. So I'm going to first subtract 81 from both sides. Okay, so I get B squared is equal to 4 minus 1 is 3, 14 minus 6 is, or minus 8 is 6. Okay, now to get B by itself, last thing, get rid of the squaring by taking the square root. So I have B equals the square root of 63. That is not a perfect square. So I'm going to break it down to put it in exact form. So 63, I could break into 9 times 7. 9, I can go further to 3 and 3. There's a pair. 7, I can't break down further. So B, in its exact form, 3 is out front, and the 7 is underneath. Okay, there's no units on these numbers, so I'm going to leave it like this. I forgot here, these ones were given in inches, so I should also put inches on the 17 so that those units match. All right, guys, that's it for this video. Thanks for watching.